Now we'll look at the second relational algebra operator, which is the selection operator, and this operator allows us to select rows that satisfy a particular selection condition, and the result of performing this operation is also a relation, and the schema of the result is the same as that of the input relation. So for example, if we have this relation and we call it S2, then if we perform the selection operator with the selection condition rating greater than 8, then the rows that do not satisfy this condition will be removed. For example, the second row has rating equal to 8, which does not satisfy the condition. The condition is that the rating should be greater than 8, so this row is removed. In the same way, the third row is also removed because it does not satisfy the condition 5 is less than 8. And now if on this result we want to perform another operator, which was the projection operator that we discussed in the earlier slides, with the projection list consisting of the attributes sname and weighting, then this means that we have to remove the first column SID because it is not present in the projection list, and we also have to remove the last column, which is age, because it is not present in the projection list. And the resulting table or relation, it consists of columns sname and weighting and rows, 2 rows that satisfy the selection condition. So we looked at how the selection operation is performed, and we also looked at how we can combine 2 operators so that we can perform projection on the result of the selection operator. The notation of the selection operator is that we use the row symbol, and the subscript, it consists of the P, which is the selection predicate, and then in brackets we write R, and here R can be the name of a table or it can be another query. The predicate P, it can be either simple or it can be complex, and in the simple case we can have the condition as attribute 1 is equal to attribute 2, and we can also have attribute is equal to a constant value, and we can also use less than or greater than symbols instead of the equal signs. And the complex selection predicate, it consists of the logical operators and, or, and not, and in the first case predicate 1 and predicate 2, it means that the condition has to satisfy both the predicates predicate 1 and predicate 2, and in the second case any of the predicates, if any of the predicates is satisfied, then the condition is also satisfied. And the third one, it means that negation of the predicate is the condition. Now we look at other operators such as the union and set difference operators. Both of these operations, they take 2 input relations and perform the operation on them, and these input relations, they should be union compatible. By union compatible we mean that both of them should have the same number of columns or attributes, and the corresponding columns in both these relations should have the same domain or type. So now we'll look at the example of the union operator. Here you can see that there are 2 relations S1 and S2, and if you want to perform the union of S1 and S2, then the result would be this. And you can see that in the resulting table the tuples of S1 are written and then the tuples of S2 are written, or we can say that we perform the union on the tuples of both the tables. So the resulting table consists of the tuples present in all the tuples that are present in S1 and S2, and the duplicates are also removed. Now we look at another operator, which is a set difference operator, and here we have 2 relations S1 and S2, and if you want to perform the set difference operator S1 minus S2, this means that the resulting table will consist of tuples in S1 present in S1 that are not present in S2. So the only tuple in S1 that is not present in S2 is the first one, consisting of SID 22. In the same way, we can have S2 minus S1. This means that we retrieve all the tuples of S2 that are not present in S1. And in this case, the tuples with SID 28 and 44 are the only ones that are not present in S1. Now we'll look at the last basic operator that we are going to discuss in this presentation, and this is the cross product operator. The cross product of two relations S1 and R1, it means that each row of S1 is paired with each row of R1, and by this we mean that every tuple of S1 is appended to every tuple of R1. We'll look at an example of this in the next slide. The resulting schema has one field per field of S1 and R1 with field names inherited if possible, and we can also have a naming conflict in the fields. So by naming conflict we mean that both S1 and R1 have a field with the same name, and in this case to rectify this naming conflict we have to use the renaming operator. So now we'll look at an example of the cross product operation. We have two relations S1 and R1, and if you perform the cross product of S1 and R1, the resulting relation is this, and here you can see that each row of S1 is appended with each row of R1. So for example, the first row of S1 with SID 22 is appended with the first row of R1 with SID 22, and it forms the first row of the resulting relation. In the same way, the first row of S1 with SID 22 is appended with the second row of R1 with SID 58, and this forms the result of this append. It forms the second row of the resulting table. In the same way, the second row of S1 is appended with the first row of R1, and second row of S1 is appended with second row of R1, and so on. So this was the last operator that we discussed for the relational algebra operators, and this is the end of the presentation. I hope you enjoyed the presentation. Until next time, thank you.